Welcome. This is a workshop to support the Aventus 2.0 hackathon at Dayanand Sagar College of Engineering in Bangalore on 18th and 19th of May. So we as Cellstrat are partnering with the college Department of AI/ML to support this hackathon. So this set of workshops relates to that. And both the students from the hackathon teams and our AI research group community are welcome in these workshops and also to submit their entries for the hackathon. So with that, let's invite our presenter today, Bismillah, to present this session on MLOps. So Bismillah, feel free to share your screen and you can get started.
Yes. Can you confirm you can see my screen and
Yes, all
yeah,
good.
okay. Okay.
Just hide the sharing thing below. Yeah.
Okay. Good afternoon, everyone, and welcome to today's session on architecting MLOps for computer vision in AWS. So today I will walk you through these topics. So we'll start with an introduction to MLOps. We'll understand the use case and why it is important to apply MLOps for such use cases. And then we'll get into the MLOps solution overview and get into the details like different workflows like data labeling workflows, model training, and finally how we can deploy this model into the vision. So let's get started. So what is MLOps? MLOps stands for Machine Learning Operations, and it is basically an equivalent of DevOps, which is applied for the software development process. So DevOps sets a standard with the set of standard practices for software development that makes the development process more efficient and also make it more easy to deploy and manage the enterprise grade applications. Now, the software development through DevOps has matured, right? And if you see long back, such practices were not there, and it was really very difficult to manage, develop, and deploy these enterprise grade applications. Now, with the advent of machine learning and artificial intelligence, now there are many machine learning models that needs to be managed at enterprise grade, and it becomes very difficult if you don't have a good set of practices for automating and managing these machine learning workflows and deployments at scale. And MLOps is what is recommended to solve these production level challenges. So if you look at this pictures explains the complete life cycle of a machine learning development and deployment. It starts with data sourcing or data collection. Then, depending on the uh, machine learning problem, we label the data accordingly. And once we have the data labeled, we should have a good practices to version this data and track different versions of data, because the data evolves over a period of time and we need to keep track of these different versions of data set. Once we have a data, we need to train the model. And this is a very iterative process as shown in this diagram. So it starts with the model architecture selection, and then we train that model on a particular data set. And once we train the model, we evaluate a model on a particular set of evaluation metrics. Now, this is an iterative process. It is very empirical in nature. We need to do a lot of different experiments, a lot of different runs, tune different parameters, to find out the best combination of parameters and the best combination of model architectures. For that, it would be very cumbersome to actually track different experiments and compare different models performance and select the best one. And that is where an important tool comes into use, which is an experiment tracking tool. Okay, so in an experiment tracking tool is very essential in order to manage all these experiments that you do in order to come out with the best model that suits best to your use case. Now, once we are ready with our model, we need to take it to the deployment. And but what we will happen is once we release the first version of the model, we keep improving this model based on the improvement in the data sets, or maybe there will be feedback coming back from the users, and based on the feedback we will do some adjustment to the models training or the model architectures, or collect some more data to come up with a much improved version of the model, right? So then soon you will be having different versions of the model. Now then comes the necessity of versioning and tracking different versions of this model. Then it helps in auditing and make sure that uh, our models are tracked properly and organized in a structured way. So this is where the model management comes. So now we have the data management, then we have the model management, and then we also, once we have the model, we deploy it and we need to monitor that at the production. Like when the people are actually using it, we need to monitor that model, whether there is a data drift or a model drift. Then we need to give that feedback back to the training, and then this process continues. And this entire thing is called MLOps. Okay. Now, as we understood that there are a lot of nuances, a lot of integrity details that is involved here. It is not so easy to implement this and make this an end-to-end fully automated system. Okay. Now, what are the four key principles and in MLOps is built? So the first one is called version control, right? So we have different ML assets in our machine learning workflows. One important asset is the data set. The other one is the model architectures or a different model types. And the third one is basically the model artifact that comes out of your model training. So since we understood from the previous slide that this is a very iterative and very evolving and it keeps changing, we need to have a good version control of these different ML sets. The second key principle that MLOps is built on is automation. Okay. Now, there are different key pipelines in this machine learning workflows. One could be a data pipeline, another could be a model training pipeline, another could be a model evaluation pipeline, and then a model deployment pipeline and a model monitoring pipeline, right? There are different pipelines that you will implement, and then these pipelines work together to actually as a complete end-to-end AI product. Okay. Now these pipelines needs to be automated. Like when there is a new improvement that is uh, tested and verified, and you want to update your machine learning model or your AI model, this needs to be done in a more automated way. Then only you will have a good repeatability and consistency of your AI product, and it's more reliable as well, because there is a lot of chance that when you do it this in a more manual way, it's very inefficient, and there is also a lot of chance to get errors. Okay. And we know that it is in software we have this continuous integration and continuous deployments. We call it as CI/CD, right? Now, once you have the different components of machine learning pipelines, now this needs to be wrapped up in a more CI/CD um, way of working. So we call that as continuous X. So instead of continuous integration, since we are most machine learning specific, we do a continuous training on like new data or new model types, etc. And finally, the key principle is the model governance. So we need to have a very structured process to review and validate the model's outcomes. And also once you deploy it, you need to monitor, and this structured process should be implemented so that we have a continuous monitoring of the model and the data. Now, when you come to MLOps, there are different levels of maturity in terms of MLOps implementation. Not all the companies are at the fully matured MLOps implementation. Also, it is not easy to directly jump into the fully automated level of MLOps implementation. So there are three levels basically: level 0, level 1, and level 2. Level 0 is where every step in your machine learning development and deployment is manual. So you just open up a Jupyter notebook, you start in installing all the Python libraries, and then uh, you also do not track those Python libraries. You just do the data importing manually, and then you do the training and evaluation. And once you have a good model, you just copy and paste it, or copy and put it into some sort of network drive and give that link to the, let's say, the software team who is deploying this, right? There is no any proper tracking or any proper automated way of doing it. The second level is a little bit better than the level 0, where you do implement some automation, but not the full end-to-end automation. So what you implement is machine learning pipelines. You have one for training, one for data preparation, and one for let's say evaluation, and one for like deployment. So you have pipelines. So instead of like manually developing those in Jupyter notebooks, you would have a more scripted way of doing it, and you could run those pipelines based on certain command line arguments. So you can just pass the updated version of the dataset as one command line argument, and then the entire pipeline could run it, right? So instead of you go and clicking all those Jupyter cells. But that is not the end. The end or the ultimate goal of MLOps is to have a complete end-to-end together with CI/CD pipelines, which means whenever there is a new event taking place, and when I say an event, this could be like new data being collected and prepared and then pushed into the data pipeline, which means then the next step in your workflow, which training, should be triggered automatically. Okay. And once you have training is completed, the evaluation should take place automatically, and then the model should be deployed to the production in a more automatic way. Okay. So everywhere is configured, everywhere the workflow is configured, and whenever a particular event happens, the next step is triggered automatically. So any questions so far before I go to the next?
So, friends, feel free to ask your questions. So, AI and Gen AI is awesome. Incredible new innovative apps are coming out, and many startups and developers are working on them. But deploying these is a second level challenge. So that's what is being discussed here, how you can set up cloud infrastructure for deploying your AI solutions. So that area is called MLOps, so machine learning operations on the cloud. So feel free to ask a question in the hackathon. Definitely the preference will be to see full stack solutions, right? Not just a Jupyter notebook for the AI entries. It will be nice to see full stack launches. So hence the knowledge of cloud infrastructure, MLOps, Streamlit, class servers. These are important for full stack launches. So let's ask a lot of questions. So we are ready for full stack launches in the hackathon.
Yeah. Okay. So in the interest of time, I will move on. So today what we'll see now, we understood theoretically what MLOps is, what are the key principles the MLOps is built on, and what are the different levels of MLOps. Now let's take a practical use case and apply the MLOps principles to this use case. And see in practice how MLOps can be implemented using AWS SageMaker. Okay. Now let's understand the use case. Use case is very simple and straightforward. So you have an object detection problem, and you just have some parts, and then you have some defects in those parts, like scratches as shown in this diagram. And you just have building an AI-based quality assurance workflow where you just parts are being the images has been acquired, and then you have an object detection model, and then it identifies those defects. Now, what you typically do as a POC is you collect data. So you have hundreds and thousands of such images, and you use some open source data labeling tool like CVAT, and then label this. Then you have a label data set. And then once you have a labeled data set, you just open a Jupyter notebook and then use any of your popular object detection framework to train a model. And then you have a model, and then you just take it to deployment, depends on what deployment you're looking at, right? So every step here is manual, from data collection to data labeling to model training to model deployment, right? Now this is okay for at a POC level, but if you go for a production grade enterprise level uh, uh, AI, I think this is not advisable, because it is not repeatable, it's not consistent, and it is not also scalable, because it is very error prone as well. Okay. Now, how could we automate this complete process, right? A successful deployment of machine learning model in production environment heavily relies on an end-to-end ML pipeline. So you can't have bits and pieces here and there, right? And doing MLOps for a very simple machine learning problem, like let's say like a linear regression or a classic machine learning problem, where the data set is more structured, more tabular way of doing it, it's pretty easy. But when it comes to more unstructured or semi-structured data, like images and videos, or even in the latest generative AI, it is a lot more challenging. Okay, so you could take these learnings and apply to different use cases and in implementing MLOps. Okay. So that's why I said, like, implementing MLOps for computation has a lot of additional complexities. Now let's see how we can solve those complexities. So a typical workflow looks like this. So you collect images, you put it into some storage, like let's say some buckets. Then it goes to a labeling pipeline. Now the output of the labeling pipeline is a labeled data set. Now once you have labeled data set, then you have training, and then the outcome is a model, and then you take this model and deploy it to either a SageMaker endpoint, or it could also be deployed to an edge device. Okay. So how does the MLOps solution architecture looks like, right? So what we are going to see is, given the use case, how we can implement this MLOps using AWS SageMaker. Okay. So for those who don't know what is AWS SageMaker, AWS SageMaker is a fully managed machine learning service from AWS. It has the complete set of services from data labeling to training to deployment to other automations. Okay. So now let's take a look into this MLOps solution architectures. I'll walk you through the different steps and also the different components involved in it. First, let's start with the Amazon S3. So Amazon S3 is the storage bucket where we will be storing our raw images, or any kind of raw data can be stored in Amazon S3. Now, once you have your raw data collected and stored in S3, you need to label this data set so that you can train your model. So for that, we leverage Amazon SageMaker Ground Truth as our data labeling service. Now, this labeling pipeline, right? We have different steps in the labeling pipeline, which we will see it in next slides, could be orchestrated through AWS step function. So what is AWS step function? AWS step function is an workflow orchestration of AWS Lambda function. Okay, and AWS Lambda function is a serverless functions offered by AWS. Now, each logical step in your data preparation pipeline could be implemented as an AWS Lambda function, and this different AWS Lambda function could be orchestrated through AWS step function. Okay, that is basically our second step. And once this complete workflow is executed and completed, we have our labeled data set, and this labeled data set could then be stored in something called as Amazon SageMaker Feature Store. So what is Amazon SageMaker Feature Store? So Feature Store is basically a metadata store or a data catalog offered by SageMaker, which is developed focusing machine learning workflows, where you could store all the different metadatas uh, for your machine learning model training. Okay, so basically Feature Store is primarily developed for storing your machine learning features, which basically those are transformed features from your raw data. So instead of just storing the raw data and uh, doing versioning on the raw data, we actually store the features which will be used for your machine learning training. Okay, now we take that feature store, and instead of storing the raw images on the feature store, which is not possible, so we just store the metadata of where the image is stored, and what are the labels in this image. All those things will be stored here. Now, once we have it, so then we trigger or we implement the SageMaker pipeline. So here we have two things. One is a training pipeline, another is a processing pipeline. So this SageMaker processing pipeline, what it does is, since the feature store data cannot be directly used for your training, it needs to convert the data that is stored in feature store into a format that is suitable for your object detection pipeline. Okay, and that is what this processing will do. So after this processing, the training will trigger, and once the training is completed, the model will be exported as a ONNX format or any format that is suitable for your deployment. Okay. Now we also do an additional step in this step 5. What we do here is we also want to track the model trains, right? Because we'll be doing a lot of different experiments and we have different versions of the model. So we want to track those models. We need to manage these different versions of a model in a more structured way. And that's what we use model registry by Amazon SageMaker. So we store this model here, and we could pull a particular version of a model from the model registry and deploy that into, let's say, either a SageMaker endpoint, or it could also be done for an IoT deployment. Okay. So if you see this from step 1 to step 9, everything is interconnected and everything's as a seamless flow from one logical step to another, from data preparation to training to deployment and consuming this model by the users. Okay. So moving on.
Bismillah, one question. This Amazon SageMaker down truth, right? Is it labeling done manually, or is it some tool is there that because we generally use CBAT and all the tools, right?
Mhm.
So is it whatever mentioning the is it done the bounding box everything done automatically, or well, I didn't get actually.
Yeah, the SageMaker ground truth, how it works is,
Huh.
it does. There are two ways. Basically, you create a ground truth job, okay, and this ground truth job can be get done by using some crowdsourced data labelers. So basically, there are like thousands and 10,000s of data labelers being onboarded into SageMaker ground truth. Once you submit your ground truth job, so and then along with those data, or you also submit an instruction like how this data should be labeled, and this job is then distributed to this workforce, right? Which you don't know who they are. They are just all crowdsourced labelers, and then they label it and they will send it back to you for review. And then if you're happy with the data label that they have done, then you approve those job and your job is completed. Okay. But let's say if you want to make it more secure, you could have your own set of labelers onboarded into it, and this job can be assigned to just only those who you know who's working on it.
Okay, labelers are human beings, right? It's not.
So, sorry.
Labelers are human beings. I mean,
Yes, yes, yes.
Yes, human beings. Yeah, crowdsourcing. Yeah.
Bismillah, you can move forward as per your convenience. I understand there is some time limit.
Okay. Yeah. So this one is a more advanced. Okay, and so I will just quickly touch upon and then move on. So as I told you, right, until this we are at level 1, I would say, based on the slide I showed you, right? So before we doing this, we were in level 0, where everything is sort of manual. And at this stage, we have some automation there, right? We have SageMaker pipelines and things. But what we ultimately want to do is a complete automation, right? So that is where we implement CI/CD pipeline, and this is what how it will look like. So what we'll have is we have all our codes in a repository, either AWS code commit, or you could also have it in GitHubs, and then you could have a CI/CD pipeline, and this CI/CD pipeline will basically manage all these things. Okay. And for this, we are also using AWS CDK, okay, which is a cloud development kit. So, but we'll move on. Now we'll look into, I was telling, right, data labeling, training, and deployment. So I was telling that there are different Lambda functions, and then we have a step function that orchestrate this different Lambda functions, right? So how does this data labeling works? So we have a set of AWS Lambda function that does the following. So we have one function that checks if there are new images that requires labeling in Amazon S3, right? So you have 100 images, and which assume that it is already labeled. Now, if you upload some 100 more new images that is not labeled, then it checks whether there is an images that is not labeled. Then if it is true, then it creates a data labeling job automatically for you. Okay. So if there is no label, then it prepares the data in a required format and start the labeling job for you. Okay. And then once the labeling job is completed, basically the labeling job is assigned to the data labelers. They will start labeling it. It might take some time depending on the volume of the label and the complexity of the label, right? It may take from hours or maybe days. But once the label job is completed, then you will get a notification that, hey, your labeling job is completed. Now then you go and verify whether they are actually being correctly done. Once it is verified and approved, then we push that set to the SageMaker feature store. So this sequence of steps is being shown in this sort of flowchart. So these are all different Lambda functions, and this entire workflow is orchestrated through AWS Self function. So first it starts with whether there are missing labels. If it is true, then it starts labeling job. Then once the labeling job is completed, there's a verification, and then it updates the feature store with the new labels. Okay. So moving on, how can we orchestrate a model training, right? So we have a SageMaker pipeline. It's basically a workflow pipeline, and it has like 4 major steps. So first is to the processing step. Now we have stored all our data in SageMaker feature store, but as I told you, it is not directly usable for our training framework, right? So then we need a processing step that will pull the latest data from the feature store. It prepares it. It even splits it into train, val, and test, and then give that input to your training. Okay. The training step, what it does, it's very straightforward. It trains the model and it also evaluates it on the validation data set and gives you the final evaluation metric, which is MAP in this case. And we also have a conditional step, right? So we say that only register the model where the MAP is, let's say, greater than 80%. So it might do a different experiments, but it will not register each and every model because there might be tens and tens of model. So we want to only register the model that is fit to be registered. That's why we have a conditional step. In terms of model deployment, it's also use a SageMaker endpoint. So once the model is trained, we registered that in SageMaker registry, and the actual model artifacts are stored in S3 bucket. Then we create an inference script, and we have the model weights that is actually coming from the S3 bucket. We take that and host it as an SageMaker endpoint. And this could be exposed through API gateways that could be consumed in the production applications. Yeah, that's all for now. Yeah, so in summary, we looked into the MLOps. We also looked into the MLOps solution architecture. We also looked into the different steps in a little more detail. Yeah, if you have any questions, I could take it now.
Hi, Bismillah. Hello.
Yes.
Yeah, I think in the last slide you have missing one point where you're talking about like if you have 80% accuracy, then you will register that model. Okay. So before that, you have to check like is there any bias and variance available there? Because sometimes maybe your model will be overfitting because you are using only 8 pieces. So there is no testing point in there.
Okay. Yeah. Can you please repeat your question? I lost you.
Yeah. Can you open the slide?
Which slide?
like large slide, like before the summary.
This one. This one.
This one, yeah. In that you have talked about like after in that model quality, then you have 80% of accuracy. If you have 80% accuracy, then you are going for registered model. Okay? But here, if you are getting 80% accuracy, maybe your model will be overfit.
Mm-hmm.
There is, I hope there is one step required where you can check like your model will be like overfitted or not overfitted. Okay, you can check that by comparison.
Okay, yeah, sure. You can customize this however you want. I just showed here an example. This is not an sort of uh, hard rules that you have to follow these two steps. This could be customized based on however you want to make improve this. Yeah.
Okay, so means this is a normally checked algorithm.
Yeah, this is very much customizable. Like if like, I just put a very simple, straightforward way of evaluating and put a condition step to check only register model, which is greater than that. But if you want to do a more advanced evaluation step, that is also possible.
Yeah, in real time we are doing the same thing. That's fine. I understand. Okay, thank you.
Yeah, sure.
One quick question. Can you go to the 12th slide?
Go to which slide?
12th slide.
Okay.
So here it has a model registry that the model comes from the registry. What is the model artifacts? Is it the
Yeah. So the model artifacts has this things. The model.tar.gis file, where it has this inference.py file, and also the model.pth file.
okay? So the script stays in the in this artifact.
Yes,
So
yes.
the model registry is only for indexing. It doesn't actually store the model. It just references the models, right?
Yes. It doesn't have its own storage. It's basically the indexing to the S3 buckets path.
So it only serializes. I mean, just the references of the model. Okay, cool. Thank you.
Yeah. So you could just pull a particular version. Just let's say, give me the version 4.2 of a particular model. Then that will pull it.
Okay, thank you.
Yeah.
Okay, any other questions, final questions for Bismillah here? So obviously this morning we had a bedrock session by Indrajit. So that's like more of LLM orchestration. This is cloud infrastructure for ML pipelines, right? So I hope the difference is clear.
Yep.
So any final questions before we close this webinar? So, okay, so thanks a lot, audience, for joining. There is a question here. Can we use open source infra instead of AWS?
Yeah, you could do, but it will be like a lot of work. If you know how to do it, you could go ahead and do it. And AWS is a fully managed service. So it will do a lot of heavy lifting for you. So you don't have to worry about different challenges. All you need to see is how you can leverage these managed services and focus more on your use case. Otherwise, you would be putting a lot of efforts in setting up the environmental itself. This environment is already set up for you. You just go and use those services.
Right. Okay, so any more questions, please? Okay, so Bismillah, are we good? Are we done?
Yes, I think we're done.
Okay. All right. Thank you, audience, for joining. Thanks, Bismillah, for this presentation. I know
Yeah.
you stepped in last moment, so thank you for that. And so thank you all for joining. Have a great day.
Thank you. Bye.